Hello, I'm Michael from team AdUpSense, Sweden. We're here to present our electrochemical approach to this year's SensUs competition, or challenge, rather. Yeah. So, at the heart of our sensor, we have two simple components, a potentiostat and screen-printed electrodes. These two combined make up a sensor platform that's incredibly small and can basically fit in your hand, just like this one. The screen-printed electrodes by themselves are both cheap and disposable, and most importantly, they're able to be modified. And this is exactly what we did. We modified our electrodes with graphene oxide, a rather novel material, and this allowed us to covalently attach anti-adalimumab capture antibody through the use of very standardized EDC NHS chemistry and protocols. Now, with all of this, how would one perform a measurement? Yeah. So one would simply have to just let only 4 microliters of a sample incubate at the electrode for around 15 minutes. The excess would then be washed off, and 50 microliters of a probe solution would be added. 30 seconds later, using differential pulse voltammetry, you have your result. But so what happened during these 30 seconds then? So transduction in itself is both label-free and indirect. To generate a signal, we use an electrochemically active chemical which can undergo redox and hence produce a current when reaching the electrode. This is what we call the probe solution. In our case, it's a very standard reagent, hexacyanoferrite complex. Now, with an immobilized surface, the current you get will basically become our baseline. With addition of analyte, immunocomplexes due to the specific antibody-antibody interaction will be generated. So therefore, the current is proportional to the amount of these generated immunocomplexes, because as they hinder probe from reaching the surface, you get less and less current. And this can be translated into a concentration, basically. Yes. So the result then looks something like this. Our biosensor shows to be quite accurate in buffer. And unfortunately, we did not have time to put this on the slide because it was too late. But recent development has showed that actually it's quite accurate in plasma as well, which we're very proud of. Furthermore, the signal is actually measured as a relative change from the baseline. And why is this important? This means that each electrode is actually independent, and this removes inevitable tolerances due to, say, electrode manufacturing. So to further improve ease of use, user-friendliness for both patient and doctor, we developed an app for the platform. The app has capabilities to wirelessly, by Bluetooth, process the data from a measurement via calibration curve converted into a concentration, and this information is then available to both doctor and patient through a login and authentication key. Furthermore, the app also promotes open line of communication in the app between, say, doctor and patient. So, to conclude, we present to you a extremely compact, user-friendly, but most importantly, incredible simple, but still accurate sensor. Thank you very much.
Thank you for the presentation. So you didn't mention it, but in your team result document, you mentioned that you had to incubate at 4 degrees Celsius. Were you able to optimize that, or are you still doing all the incubation and measurement at 4 Celsius?
So you mean the immobilization now?
Let me double check.
Yeah.
Because so that's the incubation of the antibody or the sample, because it wasn't clear to me when I read the document.
Okay, so the immobilization itself we do in 4 degrees. That is correct. The sample incubation, though, is done in room temperature.
Okay. So when you prepare a chip, you do it at 4 Celsius,
Yes,
and
correct.
then you measure at room temperature.
Yes.
So one question, you have shown us the calibration, but it goes up to 2.5. So you have updated results on this, or have tested higher concentrations?
It seems, as far as we know, it seems to cap off. It does a bit what it wants sometimes, but it's somewhere in the 2 to 3 micrograms per milliliter range.
Okay, thanks.
I can follow up on that. So, do you have any ways to improve the dynamic range of the sensor, and does it go much lower as well in concentration?
Well, I would say that more work could be needed. We haven't 9 months really. It's not that long to develop a truly functioning sensor. That is something that has to be tested. But the method we use for transduction, the differential pulse voltammetry, is really sensitive actually. So I would not be surprised if it could go lower.
It's a very lovely functioning principle. If I'm not mistaken, though, the graphene oxide, together with the carboxyl group, also has a bunch of aldehyde, epoxide groups, etc. It would be my fear that as you apply your sample plasma, say, proteins other than the adalimumab would bind covalently if giving enough time onto the graphene oxide and prevent your probe, what's the name, ferric cyanide,
Yes.
to get onto the graphene oxide. I haven't spent enough time to see whether you guys have accounted for that, but how about blocking those, chemically blocking those groups onto the surface to prevent those mechanisms?
That's an excellent question, actually. And we did think about that because our transduction is based on you blocking surface. If you have, say, a plasma protein blocking some surface, then you might be wrongly thinking that, oh, that's the analyte. So what we do is we block with BSA as much as we can from the beginning, actually, to account for.
How about blocking them with a small molecule, like an ethanolamine? It will bind to all the epoxide, it will bind to all the aldehydes. It's a teeny, tiny molecule, and it still maintains your surface relatively free for the ferrocyanide to go towards it.
Yeah, we actually tested it. It was in the protocol. Although we found it in the protocol, you use it to quench the unreacted carboxylic groups, basically. But we found that quenching with BSA actually did the trick much better. So if that answered your question.
So any further questions from the jury? From the rest of the audience? It is allowed to ask questions. Yes, okay, another question.
And I put another question, we have not enough time. The chips you're using, I had no time to see the team actually working. The chips and the reader you're using, what is that?
So I can go back to the... Yes. So you mean the screen printed electrode?
Exactly, yeah.
So basically it's a very compacted full three electrode system. So we have a working and a reference electrode in gold, and counter and working electrode in gold. Reference electrode is just silver chloride.
And do you develop them? Do you made them, or you bought them?
We bought these specifically.
Okay.
Yes. And then what we do is, as you can see, we add the graphene oxide to the working electrode.
Okay.
Yeah.
And the board, the readout, the potentiostat,
Yes.
did you make that yourself? Or?
No, we bought it as a developing kit
Okay.
from a company.
PalmSense?
PalmSense,
Yes.
that's correct,
Yeah,
yes.
I know it. Yeah. Thank you.